Okay, let's now take a look at a complicated problem. This one's going to be really interesting. The last problem we solved was secant to the third, which was, whoops, what am I doing? Which was one of the more challenging integrations that we will find. Here, we're going to choose x equals a, tangent theta, and dx equals a secant squared theta d theta. And now we make our substitutions. We've got a squared tangent squared theta. We have a squared tangent squared theta plus a squared times a secant squared theta d theta. And we pull out all the a's, so that's a to the fourth. We have tangent squared theta. This under the square root is secant squared theta, so that's secant theta, and multiplied, so we got secant to the third theta d theta. Now, at this juncture, we got to take a look and see what we can do. If we use our identities, we have a to the fourth, and we've got tangent squared theta equals secant squared theta minus 1. So we have secant to the fifth theta d theta minus a to the fourth secant to the third d theta, and that's one we've already solved. This one is equal to 1/2. I think it's secant theta tan theta plus 1/2 natural log of secant theta plus tangent theta plus c. I just want to go back and check it, make sure that I have the correct result. So yep, we do. And so now we have that. One other thing before we go ahead and throw that in there, let's take a look at more identities. A to the fourth. We've got secant squared theta times secant to the third theta d theta minus a to the fourth secant to the third theta d theta, and this is equal to a to the fourth. Now, secant squared theta is equal to 1 plus tangent squared theta, so we have secant to the third theta d theta plus a to the fourth. Now this is tangent squared theta, secant to the third theta d theta minus a to the fourth secant to the third theta d theta. So it looks like we have two terms that cancel out. And all we have is the second term. Well, you know what? That didn't get us anywhere, did it? It got us to the original. It got us back up to there. So that is not a useful. That's not a useful. That was not a useful choice. You see, this is where making the proper choices is essential. So let's go back and take a look at what we can do. We do have secant to the fifth d theta minus a to the fourth secant to the third, which we do have an answer for. And what we do is look at let's see. We got to use an integration by parts. So we're going to have to use a UV integral. Let's stop a second and take a look at what we've got. What we're going to have to do is we're going to have to go back to this step up here, and we're going to have to choose. Let's go back up to this this step. This is where mathematics, it's good to have an eraser because sometimes we have to start from scratch. We don't exactly have to start from scratch here, but we got to take it back a step. So here we use, let's try U equals secant to the third theta, or secant theta, yeah. Secant to the third theta, and du equals three secant to the third theta tangent theta d theta. Let's give ourselves some room. We'll remember this solution later. But we want as much uncluttered board as possible. V equals tangent theta, and dV equals secant squared theta d theta. So let's take a look at what we have. So using integration by parts, we got uv, so we got tangent theta secant to the third theta equals, now udv is secant to the third dv is secant squared. So what we do is, u dv, so that's secant to the fifth d theta minus or plus v du. So that is 3 secant to the third theta tangent squared theta d theta. So this, rearranging around, we got 3 secant to the third theta tangent squared theta d theta equals tangent theta secant the third theta minus secant to the fifth theta d theta, and then we got secant to the third theta tangent squared theta d theta equals 1/3 tangent theta secant to the third theta minus secant to the fifth theta d theta. There's a 1/3 in front of that. Okay, so let's see what we've got at this point, at this juncture. What have we got? What have we got? Let's rearrange things a little bit. Okay, so let's see what we've got. Third tangent theta secant the third theta minus 1/3. Okay, secant to the fifth is equal to secant to the third theta times secant squared theta. So we have we got secant to the third theta d theta plus tangent squared theta secant to the third theta d theta and that is equal to, all right, 1/3 tangent theta secant to the third theta minus 1/3 secant to the third theta d theta minus 1/3 tangent squared theta secant to the third theta d theta. And now we've got this on both sides, so we have to the third theta tangent squared theta d theta. Okay, so now we have 3/3 4/3 secant to the third tangent to the squared theta d theta equals 1/3 tangent theta secant to the third theta minus 1/3, now secant to the third. That is the interesting problem here, because we had the solution. So that is going back to that solution, which is one half. Okay, 1/2 secant theta tangent theta plus 1/2 ln secant theta plus tangent theta plus c. Now we have our answer, and let's give us some room to write. So we got here secant to the third theta tangent squared theta d theta I lost my A in there somewhere. So we're going to have to add an A to the fourth somewhere. Okay, but let's go through this. So this is 3/4, so this is 1/4 tangent theta secant to the third theta minus 1/4. but that's 1/8. So 1/8 secant theta tangent theta minus 1/8 natural log of secant theta plus tangent theta plus c. Now, we have an a to the fourth, so we have to get our a's properly. So this has a to the fourth out in the front to make it equivalent to this up here. So this is a to the fourth, a to the fourth, a to the fourth. So far, so good. Let's erase some of the little marks. Okay. This was a really complicated one. One of the more challenging problems. So now going back to our original variables. We have this expression is equal to a, let's see, nope, we have to get rid of that and go back. This was equal to x squared times the square root of x squared plus a squared dx is equal to, now we have to get our original values back. So let's take a look. Where do we have space? Okay. We have theta xa. That's tangent theta. So this is a squared plus x squared. Tangent theta. So we got a to the fourth over 4 times tangent theta, which is x over a, and secant theta, secant to the third, so this is secant to the third, so we have this x squared plus a squared over a to the third minus a to the fourth 8 times secant a squared plus x squared over a. Tangent is x over a minus a to the fourth on 8 natural log of tangent plus secant. And this is it. Now we can do a little bit more here because we know that we've got this. So that we get rid of. And we're going to just put x over 4, and this is raised to the third power, so this is squared to the third, and this one is a squared, so we get that right. Let's see, move this over a little bit. A squared x over 8, and then this just x squared plus a squared, and that's it. We've got it. Oh my goodness, this was quite a problem. But that's the solution. Now that is one long solution. And it involved a higher order of secant. Secant to the fifth, actually. So this is our solution. And that was quite a challenging problem. And it took us to understand how to solve secant to the fifth and secant to the third, both very challenging problems. So that's the solution, and it's a bear. But that's how it's solved. So whenever you go to a table of integrals, you'll be able to see, you'll know how to solve that one. Whew, that was quite a problem in itself. So that's the solution I have in my notes. Now here we go. Oh my goodness. We're masochists. We're mathematical masochists. That's what we are. Here's a problem right here. X to the third times x squared minus a squared. So we can choose x equals secant a secant theta, and dx equals a secant theta tan theta d theta. And now we make that substitution. We have a to the third secant to the third theta times a squared secant squared theta minus a squared, and dx is a secant theta tan theta d theta. Wow. Now we abbreviate everything. We get a to the fourth. Let's give ourselves a little room here. equals a to the fourth. That's correct. Now we got secant to the third theta. This is 1 minus secant squared theta, or let's see, I'm sorry. Oops. We have tangent squared theta equals 1 minus, or no, secant squared theta minus 1. So this is tangent squared theta, and we got secant theta, tan theta, d theta. So here we got a to the fourth secant to the fourth theta, and tangent squared theta d theta. Okay, so now we have this. We got a to the fourth secant squared theta times secant squared theta, but that's times tangent squared theta plus 1 tangent squared theta d theta. And now we have two integrals. We got a to the fourth secant squared theta tangent to the fourth theta plus a to the fourth and secant squared theta tangent squared theta d theta. Oh my. U equals tangent theta and du equals secant squared theta d theta. So here we got a to the fourth u to the fourth du. I had forgotten to put my d theta in here, so d theta plus, okay, plus a to the fourth u squared du. And now we have a to the fourth u to the fifth on 5 plus a to the fourth u to the third on 5 plus c. And we have a to the fourth tangent to the fifth theta on 5 plus a to the fourth tangent to the third theta on 3. This, I made a mistake here. That's got to be 3 plus c. And now we go back to our original functions. getting a little, maybe call it quits after this one. So here we had x equals, x on a is secant theta, so let's see, x on a, let's give that up. X on a theta, and this is a squared plus b squared equals x squared. B equals square root of x squared minus a squared. So x squared minus a squared. Now we go back, we got tangent, so we got a to the fourth of 5, and we have x squared minus a squared on a to the 5th plus a to the 4th on 3, and x squared minus a squared on a to the 3rd plus c. And so we cube root of x squared minus a squared on 3 plus c. And that's the final solution. And if you noticed, we have x squared minus a squared. This is to the 1/2, but that's raised to the 5 and 3. So we have x squared minus a squared to the 5/2 and x squared minus a squared on the 3/2. And that's what we have represented. So that's what this is. This wasn't as bad as the previous integral. So